My name is Linda Kenny Sloan. Informally, Linda Sloan will do fine. I tend to use my full name on badges and formal statements for the press or whoever may be listening. But the Experimental Spacecraft Society is a group that was formed originally 3 years ago, 1990. The leader of that group was Gig Enough. Dr. Gig Enough, a physicist at the time, employee of IBM, and she had some nice dreams and a vision, but not enough people to get a project really up and going. We have started collecting more people, trying to get more people in the group, developing incentives as well as ideas for payloads to get into orbit. We have one project. This is the start of that you see here, the hardware. It's essentially a camera in a box is what it started out as, and it's a video camera that we're hoping to put aloft in a suborbital launch. And we got an invitation to put something up by an angular rocket group. So we're starting to, that we have been working around that. But we are also starting to increase our options for launch providers. Welcome to the Experimental Spacecraft Society.
Glad to see you, period.
All right.
Then I'll contact you a little bit. Is some of the communications being offered via email over the internet?
They're going to be again soon because things have been a little shaky on internet communications because one of our members used to provide those and now isn't. I think we're going to be able to restore that, assuming certain conditions. One way or another, I think we'll be beginning to post again on internet, but it won't be. I'm not sure what thread it's going to be on or message things.
Well, it was just email, not a Usenet news discussion last I heard.
Okay. I'm not familiar with all the intricacies of internet yet, but I'll be getting them.
There isn't a...
Tell you what I'll start doing here, just to get an idea of who we're talking to. I know there's at least one or two members, other than the people who are up here, already here. I'd like to find out a little more about the group here, what your ideas are. As far as why you're here, who you are, where you're from. Can we just do a little circle? Starting over here, if we can.
I'm Ed Kiker from Kansas City, from Heart of America chapter NSS.
And I'm Robert Stout, the founder of the Heart of America chapter in Kansas City. We're both real interested in the Delta Clipper, which is an experimental spacecraft, and this looks like a way for the chapter members to do something on a smaller scale. I didn't even know you existed until I came to this conference. So I thought, hey, I need to check into it. I can support Delta Clipper and be young and go behind it, but this is something maybe I can do and get my hands dirty.
Go ahead.
Okay, Frank Bynum. I have had communications with the ESS people in prior incarnations. In the sense of founding one of the ISDC's background in engineering, etc. But there's, as I alluded to, a period of time with not communication, and I'd like to know that if possible.
go next.
Okay, my name is Randall Severy. I've been kind of a lurker on Genie as far as my predominantly involvement with ASS. I thought I joined about a year and a half ago or something, but there was a mix-up in the name or something. I think I formally joined only about 2 weeks ago. I've had an interest in doing something real, talking about something all the time, but I have a somewhat light background in the hardware side, being more involved in computer software, but I hope to be able to do something sometime.
Okay. The fellow in the back, we're just getting to know each other here a little.
Well, I'm Scott Pearson. I don't know what you really want to know, but
Who you are, where you're from, why you're
I'm from Nashville, Tennessee.
very star.
I'm just kind of curious about what's going on here.
Okay.
My name is Steve Williams. I went to Virginia Tech, got an aerospace degree and working on a computer science degree, and I just came to check things out myself. Our chapter is looking into trying to find a project that will get members more involved. So this is one thing. Experimental launch vehicles will be another. So.
Okay.
I'm Dan Morsick, just graduated from the University of North Carolina at Charlotte, degree in mechanical engineering. I started working at Edwards Air Force Base, Phillips Laboratory. I co-opted out there for about a year on SDI projects. I'm a member of the Experimental Aircraft Association, and I saw it for Experimental Spacecraft Society, so I figured I'd check it out.
Glad to have you here.
I'm Terry Sanders from Huntsville. I'm one of the ground controllers on the shuttle missions here at Marshall Park, and just came to see what you guys are doing.
Hector, the line of Northwest Mexico, Tijuana, to San Diego. You are in LA, right?
Yes, Los Angeles area.
Okay, I am the founder for the Instituto de Desarrollo de Tecnología, is Technology Development Institute in Tijuana. We are trying to set some little rockets in space. And that's the reason because coming people to see what you're doing about the experiment.
My name is John Turner. I'm the president of the State Flight Society here in Tennessee, and excuse me, back in Tennessee. That's close. And I've got a background in physics, finishing up my master's degree.
All right.
Yeah, leave it to us three.
That's great. I guess we should introduce ourselves.
I thought maybe you'd already done that.
You weren't here.
Yeah.
So I thought we better.
Yeah, I'm Jeff Root. I'm from Minneapolis, and why don't you just give us your names?
Well, I've done that much.
Okay,
Like they know my name and
We're both.
guess what I am.
We mostly know each other from communicating on Genie. I presume you've already mentioned Genie. If anyone doesn't know what it is, it's simply computer communications, BBS. Up until now, it's only cost $5 a month, which is the reason we selected that as the form of choice for communications, because we're spread out all across the country, and there's no concentration of people in any one small area. Cost is going up now, so I'm not sure what's going to happen because of that. But up to this point, we have been working mainly on one project, which was a payload and recovery system for a rocket being developed by the Pacific Rocket Society. We got started with the basic idea of sending stuff into space without knowing exactly what that stuff would be. And when this opportunity came along to send something up on the Pacific Rocket Society's rocket, we said that sounds like a good deal. But so far, it hasn't turned into anything. And what I would like to do is to just look at ideas in general for going, for new projects to go into space and discuss those. If we can come up with some new projects, we could start working on them right away, and the sooner we can get it into space, the better. So I'm hoping that maybe some people here will have ideas of projects that they would like to do. I think that it's kind of weird that we started as an organization that wanted to put stuff into space, but we didn't have any specific ideas of what we wanted to do. So we were really going at it backwards, but that's basically what we are, is people who want to do stuff in space. And hopefully by doing it, we can make it easier for other people to send stuff into space. And it should become easier and easier as it goes along. Should I give a history of, we got started with when Gay Knopf, a lecturer in physics. Okay.
I've done that.
Okay. She got the organization started, and there were perhaps 50, 60 people who expressed interest, and those people who were able to get on the Genie are mainly the people who have continued. So we've left some people out very unintentionally, and we're looking for any means of communication possible so that those people who are interested in working with us can stay in contact. That's the main problem, is keeping in continuous contact so that you can do something. I think the people here all want to do something, but if you're separated by space, you're not going to be able to get something into space.
What remains of the written exchanges that went through Genie? Do they still, are they still physically present?
Yes.
Could they be put down to a file and archived and
Yes.
sent upon request?
I just discovered about 3 minutes ago that the messages that I have on disk, which I was going to have available for you here, seem to be missing. But I was going to have all the messages that I have recorded, which began in January of '91, or I believe that's correct, almost to date. Those will be available. If you want them, you can get them from me.
Check at the registration desk. That's where I left them.
You found them?
Yeah, you left them sitting by the camera. I didn't know whose they were, so I turned them in there, and that's where the handle lost and found.
That's right. I remember putting them there. Okay. Thank you.
Is
I was afraid that I left them at Kinko's.
MS-DOS formatted?
Yes, that's correct. They're plain ASCII files.
Are there
Just
any,
paper or
systems,
what is it?
Get a
available on the
box of
site
discs.
where you can do files transferred to disk?
I think there is. I haven't found out about that for sure yet, but I've got I've got 2 copies of it. And you can have both of those copies. I mean, anyone here can
has
have
like
them.
discs.
What size disk?
It's, what is it, 14.4, high density 3.5 inch disc.
1.4 megabytes.
Great.
Great.
No messages in the SSD.
That I'm not surprised that most of us are right here.
Yeah.
I have printouts of some of the more recent messages. These run January of this year, and the last messages here are May 22nd. So this is just a sample printout. Should we pass these around?
It's a good idea.
What size rocket are y'all looking at that somebody's working on?
The Pacific Rocket Society has put together a unique combination of fuel and oxidizer. They're planning on a 6-inch diameter by 17-foot tall rocket that's going to be propelled by liquefied propane and liquefied nitrous oxide, laughing gas. I believe it's the nitrous oxide that they also need to keep it cool in order to keep it liquid.
I think it had to keep it pressurized.
Yes, it has to be pressurized. The pressure isn't very great, but it's
It's not even very fast.
so it's going to be a 6-inch diameter aluminum tube. The different tank sections are the tube. I mean, it's the skin and the tank are one, but the sections will be fastened together somehow. We've had kind of a hard time getting specifics from them exactly what they're doing, but that's mainly because the machinist was injured in an accident a year ago and he's only recently begun work on it. Again, I understand that they finished drilling the injector holes in the motor, so that's encouraging news. Oh, you have one of the diagrams. I also have a drawing of the actual dimensions of the rocket. Although the dimensions aren't shown on here, it's drawn to scale. And what we want to have for a payload compartment, I'm going to pass this around because it's too small to see. There's no details in here because we haven't figured out what the details are yet. But I figure about a 15-inch long nose cone from the top of the recovery payload compartment. This section down here would be all the space we have for instruments and electronics and whatnot. This section in here would be the main parachute. And up in here, we're going to have a drogue chute, which will come out of that.
So your instrument bay is about 8 inches, 10 inches long?
8 inches long is what I figured. These numbers are not fixed. You can make them.
What kind of altitude do they expect to make?
They're, I would say, somewhere between 15 and 20 miles. I believe the number that they gave us most frequently was about 17 miles. We've heard a range of numbers.
How much time would that give you in essentially free fall before you get significant buffeting and so on?
I haven't calculated that. I believe it was
Essentially spaceport.
I'm pretty sure it would be less than, well, significantly less than a minute.
At 15 to 20 miles, you still have an awful lot of atmosphere.
Yeah.
Well, about 10 miles altitude is where the troposphere turns into the stratosphere.
The reason for the rocket is simply to do it. And I think the reason for the payload is simply that it was a good symbiosis of the two groups.
Well, I think it's good. I'm just trying to think in terms of best use that we can make of it.
I have a question. This one message, May 8th, is referred to the Tripoli launch in Kansas. Where in Kansas?
I haven't heard any details on that.
We're from Kansas. We haven't heard that
What city or near where? Does anybody know?
The chap who put that on isn't here, and he's never really posted up precisely where in Kansas it's going to be. So,
Oh, it hasn't happened yet?
No.
Okay.
Matter of fact, has he even posted a date on this thing? I don't. He's just said that they're going to hold it. I don't think he said either when or where. So I guess we ought to jump on him and say, okay, where?
That was a relatively recent piece of information to us. We haven't checked that out yet.
I couldn't tell that if the past tense message about the launch in Kansas that has happened or it's going to happen.
No, it's upcoming, but we don't.
Sometime
know.
this summer.
Well, have you heard what the nature of Tripoli is?
Sorry? No.
Have you heard of NAR before? National Rocket Association. Well, as far as I can tell, Tripoli is one of the additional groups that has sprung up for, I guess, generally higher performance rockets than is sanctioned by the NAR contests. And,
Bigger engines.
Bigger engines, and maybe with a few less restrictive insurance-related restrictions on them. They will be trying for a low profile in order to not have many crowds come past that might be in danger of things falling on their heads.
This is a,
Apropos of that, I was with a group of students that did a rocket in, let's see, it was about 1964. And it was about 20 feet tall, and it took off like a scalded cat. It went straight up in a clear sky and disappeared. We never found out where it came down, and we were afraid to ask. So, yes, these are important considerations.
the way I figure it, this is how the Pacific Rocket Society's rocket would be lowered back down by our recovery system.
Yeah.
The balloon would come out right after apogee. Most likely, it would be triggered by an altimeter. You guys should bring that out first. Bring them out before. Where is this stuff that I just brought there under the desk? That's the readout box. Okay. This is an altimeter. It's supposed to be good up to, and I forget what that is, but it's supposed to be good up to an altitude considerably less than what we expect the apogee to be. However,
that was advertised, says advertised to 100,000. At least that's,
okay,
numerous times.
theoretically can measure up to 100,000 feet. However, the altimeter itself, the sensor itself, I believe, will probably not send a sensible, a meaningful signal after perhaps 70 or 80,000 feet. After that point, it simply deviates from a straight line so much that it's no longer meaningful. However, you can still tell whether it's going up or coming back down, even though the number isn't going to be an actual value of altitude. But this little thing here is the air sensor, and it will store the altitude values at regular intervals in here. They can be read out with this box over here. You plug it in after you recover the rocket, if you do, and read it off. This card here is triggered by the computer on here to in turn trigger the release of drogue, which in this case is a balloon, which was donated to us by Kirby Eichen of the Australian Space Society?
National Space Society of Australia.
National Space Society of Australia. That's what this thing is here. 3 feet in diameter. And I believe this has been tested by one of our people in Illinois, and he says it works nicely. It's a balut, a combination of both. And I was kind of pleased that this came about, because this is one of my first suggestions, and I think that someone else came up with this independently of my suggesting it.
Do we have any members who have ready access to light aircraft for drop tests?
I don't think that would be necessary. You can do a drop test, even indoors or something like that. I suppose you can get greater speed from a higher altitude.
Was it
You're using the full weight that you anticipate the rocket
full
would
weight
be. So.
and a structural test item?
Good idea.
Not the vehicle that will actually be flying, but something structurally very similar. You'll be very concerned about the avoidance of pumping it up at the final moment when it hits the ground.
Part of what we can specify to Pacific Rocket is that we'll guarantee to get down. It may get a bit dinged or a few bends in the side, but it's not going to put it completely out of commission. You know, they may have to put it in the body shop, as it were. But we're telling them that our system will be enough to keep it from ending up in small pieces.
It's still good to test.
We haven't determined yet what the size of the main parachute will be, so we we don't really know what terminal velocity will be. Of course, the size of the parachute should depend on what we want the terminal velocity to be, but it may also depend on how much parachute we can fit into the available space to weight. We expect the total weight of the payload recovery section to be, I think it's 30 pounds or less. I think that's I can't recall right now if the 30 pounds is the maximum or if that's just the target weight. Yeah.
What's that your 6-inch diameter? Is that
That's
pipe?
simply what Pacific Rocket Society decided to use for their rocket.
That's not machining, right? That's not machining.
No, my understanding is that it's an extruded, drawn extruded seamless tube. And I haven't been able to locate anyone who manufactures that, so I don't know where they got it from.
Let me jump in here a little bit. Seamless extruded tubing is relatively easy to come by. But drawn tubing, after it's extruded, the only people I know that make that are Runner. And I didn't know they made it in 6-inch size. I'm not sure they still make it.
Even though we've discussed this at considerable length, I may be wrong about it being drawn. However, the salient fact is that apparently the wall thickness is quite thin. It's not normally made apparently with such a thin wall thickness. It's 0.09.
0.93?
Approximately.
Yeah, that would be the whole top floor limit that you can buy external tubing. At the place where I work aluminum tubing all the time, and normally we don't buy it less than 125. Simply because it's hard to handle because of the density. We use it uneven.
Well, I have not been able to locate anything smaller than 0.125.
Yeah, I don't think they would normally carry in stock. It gets very easy.
But apparently Pacific Rocket was able to get some in there. That's what
They may have had it custom made. I didn't think of it.
It's the custom.
The custom, the word custom is what scares me because
You don't want to do custom anything
No.
in this business.
the rocket itself is 17 feet, and our section should be
construction to
the target length is 42 inches for the payload recovery. So the total is about 20.
And you can get 12 inch.
That side holds that thin, I think it's delicate to handle or you can take it out from inches or anything.
You started out with heavy.
I think you did make them just hitting a range every single time.
They what basically they roll basically.
Does it have reinforced structures?
No.
I would imagine.
Do we want to discuss the launch of the Pacific Rocket Society, or do we want to bring up some ideas that are perhaps new? I was thinking that there are all sorts of different areas in which we could do stuff. There's weather observation, there's Earth resources observation, surveillance,
Can we sell
astronomy.
Can we sell photographs to photojournalists?
We can do anything we want. That's basically where I'm starting. We can do anything we want.
We didn't
We
mention
may-
the coffee can extension. It's about the size.
Well, right now I'm also thinking beyond that. If we can come up with an idea that won't fit on the Pacific Rocket Society or is inappropriate for it, that may be great too. We'll just find some other way to get it out.
How low or high profile are y'all looking to be? Because you are approaching a number of legal barriers.
I'm not too concerned about the legal problems. I think that those can tend to solve themselves as they go along. Apparently, for smaller rockets, you simply approach the FAA. For larger ones, approach the Department of the separate office in the Department of Transportation.
That's where you start running into some serious.
The Pacific Rocket Society plans their launch to take place in the Black Rock Desert, Nevada. It's about 25, 30 miles northeast of Reno, and there's essentially nothing there except the highway, the road. And launches have taken place there in the past many times. So I think that as long as you avoid the air lanes in that area, it's really not going to.
Well, I presume you're also talking about sticking with sounding rockets. You're not going to try to.
No, I feel that the best way to get a small payload into space is as Gaten off. I think we first brought up the idea at the very first meeting to piggyback on someone else's payload who's paying to go up into orbit. There are pretty much three levels: the sounding rocket level, the either low Earth orbit or geosynchronous orbit, where we could piggyback with a commercial payload. And beyond that, if we want to go to the moon or something, it gets really hard. The only way that's been done so far is to go through government, and it essentially becomes a government project, which takes it out of private hands.
Actually, we aren't doing it. There was a proposal by a group of Germans in 1991, I believe. They are working, an amateur radio group, AMSAT from Germany, is working on a large, very large communication satellite that will be in a 9-mile IO orbit. And a separate group had proposed to them, because the original design was a hollow, roughly hexagon-shaped structure, would have a hole in the center to adapt it to one of the Ariane 5 test flights. They wanted to mount a sun-satellite within the main satellite, which would have its own command, control, power, and propulsion systems. Once the main satellite had established itself in its IO orbit, high inclination, high orbit, they wanted to separate the sub-satellite and fire its engine up and put it on a trajectory to go to Mars. And they had done the math, and as with a lot of things, including us, what killed them was funding. They had gone to a couple of different groups, both private and government, to get the money to just build it. The hardware was evidently not much in the way of complications, and they simply couldn't get the money together. So even you can, depending on where you go and who you talk to, you can get piggyback rides out of the solar system. You just have to be fairly smart and settle for something that's small and cheap and gives you maybe one or two observations.
What was the cost factor
They need the original, well, the main satellite itself is coming in now. Let's see, they've had to change the design because Ariane Space has quit offering the adapter they're going to use. So let me think. I think right now the total cost of the main satellite is running somewhere in the neighborhood of $5 million, and they've got nearly half of that raised right now. They have begun building the hardware. Smaller satellite, the estimates vary a little bit, but it ran somewhere in the order of $1 million to $1.5 million, and they needed, because they wanted to get it built and tested fast, they needed a fast response, and basically all they got was either no or, well, give us some time, and before the time ever ran out, it was too late to get started. Basically, it just went up in smoke, and they couldn't get it done. That was that.
On the other hand, there was an article recently in Space News about an Italian group of 10 radio amateurs in Italy that put together a microsat and got 2 corporate sponsors to help with the funding. And they're launching a small microsat, I think it's a quick piggybacker on Ariane. And this is like a group that's doing on their own time, during off hours, weekends in the garage, and all that sort of thing. So it can be done.
They a couple of them work for institutes that have where they have access to the test facilities, so that helps a little bit too.
That's true. But
It also a lot more
I
people than we do.
from the introductions we did earlier, I saw a couple of people here that had,
Yeah, we had a couple people who said they were connected with space stuff, so maybe we can persuade someone in the audience to loan us some test facilities,
Yeah.
please.
with that, I'd like to say a few things myself about launching in general, which is usually a bottleneck to getting to where we're aiming for. Very simply, the last few months has been a very interesting phase in that we have done an inventory of launch opportunities. We have come up with a few backup candidates for the PRS vehicle, for JDI-0, about 2, I think. In addition, 3?
Yeah, 3 plus
Yeah.
1 by no missiles.
True, okay, 3.
The,
4 if you count 1 if we actually go to the extent of building our own rocket. But there are groups out there that are coming out of the woodworks once you start looking for launch opportunities, mostly suborbital. A few, if you look carefully, might have plans to go eventually orbital. And that's what we're finding. And earlier during the meeting was mentioned Delta Clipper. I have some information from Dr. Galvez from the Delta Clipper office on payload area in the DCX. If things work out, and I'm not offering any promises, but they are a potential candidate for a payload. After flight tests, that vehicle will not be discarded. It will be offered, possibly offered as a testable.
What did you say for payload on it? Size or what?
Very, very little. There's no payload area
I know.
marked. There's no area marked for a payload, but there are holes in it, like in the inner tank area. And there's an avionics platform that has a rack that you might fit a small box onto or something. Maybe an acoustic acoustic measurement or vibrate.
I asked him if he could cram me in there, he said that would shoot our wiggle out us all to hell.
But it's a maybe, and it's certainly nothing that's being promised to us. But it's again, another option that we need to keep our eyes and ears on. And there are other options too that we're uncovering. In fact, earlier today I had someone come up to me and say, "I got a launch opportunity." They're coming out of the woodworks. Well, we've got to be a little careful in choosing them too, assuming that we want to go higher than suborbital, eventually into orbital flights. So this is something that I'm very interested in pursuing because we want to go beyond JDI-0, obviously. And this is what this meeting is about. Where do we go from here? Should we continue with this? And if so, with PRS or to other rocket providers? What ideas do you have for payloads, opportunities? Yes, sir.
You've been looking for opportunities. I was just wondering if you would ever look at Pegasus at all. Because not only, Pegasus, if you want the whole payload, it's about $7.5 million. But Orbcomm, which is a subsidiary of OSC, is creating their little mini satellites for store and dump, and they're also creating something essentially a microsat, standard microsat plus. And they've already developed the carrier so that you can carry 7 of these on one flight.
They've already done launches, so. wasn't
No, they did. Oh, that's-
successful.
okay,
They
that's
got
right.
them
The
up,
last
they
one
just
was-
didn't quite make the orbit.
Right, that was the DARPA.
Yeah.
So, but they're developing essentially a microsat bus, which has the power systems and the communication and navigation. You know, it's all built in there, and you can just hang your experiment on the
How
outside.
much do they charge?
Now, I don't remember exactly how much. I've got some information on Pegasus itself, but I don't know how much they charge for that type of thing. But it's just something that you can look forward to in the future.
I had heard that Pegasus was open to multiple
As a matter of fact, they're
different
planning,
people.
they're planning on launching 2 to 4 per flight. Because they're only 250-pound satellites. And since Pegasus can carry 1,250 low orbit, so I've got something in mind. But,
If we could see something written on that, we'd appreciate getting some of
okay,
that.
well, I've got stuff back.
And specifically our that they're.
Yeah, I don't have anything to work on, but I've got
payloads.
like payload and dimension information on Pegasus itself. And I can get information.
Okay, essentially, we are looking for either cheap, very cheap, or free lips up.
And I have heard reference to allow piggybacks, really incredibly small piggybacks, like 5,000 piggybacks.
Any opportunities for,
free.
any opportunities for suborbital missions that would be a piggyback on
Well, they do
the
have
extended first
have
stage?
2 suborbital launchers, Arrow and something else.
I meant the whole in the first stage that you would,
Oh, something you said on the first stage? I don't know about that.
We'll certainly add that to our file, because we are continuing to put things into our file and database on launch opportunities. We're certainly pursuing those that look good.
In the smaller of the two lists of messages on Genie that I passed around, is the list of launchers that would be alternatives to the Pacific Rocket Society launch. It includes them. We thought that we could go ahead with this little up and down thing, whether or not we launch on the Pacific Rocket Society rocket. I presume it would still be the same general parameters. It'd still be 6 inches in diameter. That's really the only real constraint.
there's a hammerhead.
Pardon?
There's a hammerhead that may, such as I-4 use.
Not familiar with that.
Diameter,
It's bulge.
larger diameter for payload section.
Oh, I see. Well, yeah, of course, that's a possibility. I think that one of Pacific Rocket Society's goals was to simply get as high as possible. So we're trying to help them do that. Keeping the weight down is a classic problem that's certainly been one of our problems. The length especially keeps growing. I think that's why they ended up with such a long rocket, 17 feet tall, only 6 inches in diameter. It's pretty long and steep.
We might have some initial poems about whether or not the structural rigidity in bending is going to be sufficient given that fineness ratio.
I'll just leave it up to them.
We supply the return capabilities, they supply the write-up.
Do they have structural engineers on board? Do they have structural engineers and
Supposedly,
aeroelastic?
I think that one of the important things about this is that we're just going to do it. We aren't necessarily going to be sure that it works beforehand. If it doesn't work, it's not going to be that big a deal. So it doesn't work. Try again, maybe it'll work the second or third time.
One thing that seems to come up is that the opportunities for different size payloads come up randomly, and so a lot of these appear to be a waiting list where as long as you're waiting, you have the capability to wait for a while, you can probably Have y'all considered designing 2 or 3 different classes of satellites, say, like 2, 3 kilogram, 5, 25, and having something like that ready to go on demand?
The basic question is, what is that payload going to be? That is what I would like to hear from you. If you have ideas for payloads, hearing about that is what would make me most happy. We would start designing something to do a specific job rather than just designing a payload without having any task for it to do. It's real hard getting the motivation to do it because you're not sure what you're supposed to be doing when you're starting out with just the general desire to get something out there. If we have a specific task we can really work on it. And that's what I really wanted this meeting to do, was to define, or at least begin defining a specific question to answer.
I had two comments. First of all, about piggybacking. You have to understand, and I'm sure most everybody does, that in a piggybacking environment, it's like taking a hitchhiker in your car. You want to be real careful about who you pick up beside the highway. And I'd be very surprised that ESA would even consider having in the middle of their satellite something with as many volatiles as it would take to get out of. I'm just curious. They may have said, well, we'll tell them we'll do it. Anyway, the idea is that some of this stuff is so, they've got enough invested in it so that they don't want to risk it. If there's anything explosive involved or any little trap doors that are going to spring on them. Now, as far as the Ariane goes, the Ariane has a pocket in the top of the second stage, doesn't it?
No.
When I say pocket, I mean,
What they do is, and this Ariane is no stranger to this piggybacking. They have launched, let me see. So far they've launched close to a dozen piggybacks from various groups. Let's see, AMSAT and the USAT people, University of Surrey satellite building group have launched. Let's see, AMSAT's got 3 plus 1 they did with Weber State. USAT has launched 4 that they've built, and all this stuff is, the people who are doing it, they know. As a matter of fact, the large one, that's basically the paper signed, that's a done deal. They're going up. The only thing that changed was because Ariane, when they first started offering the Ariane 5, in their book, they had an adapter that was so big by such between the rocket and the payload. And the AMSAT said, well, you've got X many pounds left over in performance on your first mission. Can we, instead of having you hang ballast on there, just take this cone and hang a satellite around it? And they said, fine. They had the reputation that they could build these satellites. Also, they went ahead and did it. And then later on, after they started going to the commercial sector came back basically and said, we don't need this adapter. It doesn't fit any of the payloads we've got in mind. So they came back and said, guess what, guys? We aren't going to be offering that anymore. You're going to have to change your design. And they've got it now where there is the original one was a conical adapter that changed the dimension from the top of the Ariane booster down to a certain size. They would change that over to a straight cylindrical adapter on top, and now the new design they're bending metal on already is going to set down overly inside of that cylindrical adapter. I said they've ridden on Ariane 4's 3, 4 more. I can't remember precisely how many flights they've ridden on various amateur groups, and before that they had ridden on different U.S. boosters. As a matter of fact, they got started in 1963 with The first one was strapped to the outside of a, back then they called it a Thor, now it's a Delta launcher, and it just, when it got into orbit, it just popped off the second stage and it
That's really the clue, though, the popping off part.
Yeah.
And they use spring separation.
That's what they're doing.
That's what I mean. They feel safe with the spring separation. If you're going to put volatiles in there, then they're going to start thinking, oh, fire! You're going to shoot a firecracker with this? No, thanks.
No, they have already launched. Well, they launched 3. They lost the first one because the Ariane booster crapped out. But they've already launched 2 satellites to the same Polonaya class orbit. They both had their own internal motors, and the other ones were all everything is in there is loaded up, okay, fueled up. The ones that use it, and there's no motor firing while it's anywhere near the satellite or the initial payload. They kick it out with a spray, and after it's out, they get the orbit characterized. Then they send them to command. Guess what? Dummy, fire your motor, and it shoots itself off and boosts itself into its proper orbit. And Ariane?
I was just trying to address the trepidation that some the major carrier would have in carrying out a sidecar of some unknown quantity.
Well, I don't know. We might have to establish a reputation like they do, but it's not as well. That's I'm just saying.
And
Okay.
as far as so much, I was just trying to say you have to understand why somebody would be not want to let you ride along in their vehicle. That's really what I want to point out. Second, as far as payloads go, I don't know if I have anything specific, but in general, if you can include some educational aspect of this for some population or other. When I say either high school, college, whatever, to say either for tracking it or for communicating with it back and forth or whatever, you're going to be a lot better off in terms of getting support, popularity, and so on and so forth.
Are you thinking of, or are you aware of the project in Iowa? I'm not sure who it is in Iowa. It may be, I think it's the, what is it called? It's connected with NASA, the educational consortium that every state has now. They are planning on putting up a small satellite, I believe in a gas container. It'll be, I think, 18 inches high. It'll be solar powered. It will have at least one, I think maybe 2 TV cameras on it. If it has, the TV camera will actually be on the end of a boom, so that it can turn around and look at the satellite itself. And on the satellite, they're going to have a little liquid crystal display, so that people back down on the Earth can, say, write their name or put their handprint on a detector, and that will be shown on the liquid crystal display, so that people back down on the ground can see on the TV their handprint out in space at the same time they're making it. And it's going to have several other experiments on it. I think it'll have temperature detectors, possibly some kind of radiation detectors, and it will certainly have radio communications equipment for general reception and retransmission.
That certainly sounds like the kind of thing I'm thinking about that involves a significant Earth-based population other than the people that built the satellite in the first place. You can come up with a way to communicate with that beforehand. I don't know whether they would be worried about being preempted. I don't know.
So they're probably
or in space.
bulletin boards to exist in space courtesy of NASA.
There you go.
Yeah, they're open for any group that wants to get the station together and get the license. The guy here is talking about orbital science is actually about 3 or 4 or 5 years behind AMSAT. They've been flying, they flew 86 or so microsat 9-inch 25-pound cube. It's got a receiver, mass storage memory, downlink system, and it's been flying for a while now. So they also made the design available, and they have a small space on top because of the way it's built, and a set of basically layered structures. Each one basically is like, it goes through like a layer cake, and each rack. And they have on the top, they put this one in every diagram that they made. They came out with on the first TSR on the very top rack, which basically stands for the space for rent. And they went out and campaigned for anybody who had an idea and wanted to put it in there. If it doesn't interfere with us, you can do it. Weber's, the one that came out eventually called WeberSat, was the first one they applied that to. It has a charge coupled device camera in it that digitizes pictures of the Earth or the space as the satellite moves, and it can flash digitalize that and compress it and make it into a file that goes directly into the computer storage, and it can be downlinked by anybody who wants to link up to it. That's basically all it does, because in memory it eats getting those images. But they've got some other stuff that they've played with, the radiation detectors. Where I'd have to go look it up and find out.
Well, that's great, but the idea here is that you want to do something more or less accessible to somebody with a kind of a medium level technology. And if you brought it, I'm sure you can find some, if not some technical schools, some high school with some fairly bright people aboard that you can begin to get a little coast-to-coast participation. I don't know whether we're talking about relatively high inclinations to get these satellites somewhere close to the States, but
they're in a polar orbit. They went up with the 4 microsats went up with Spot 1. So they're in polar orbit. So they're regular schedule every day. You can get them on.
The Iowa project, although they are sponsored by the Educational Consortium, they're going through a large project, I guess, to raise money to pay for the thing, because they do only have a small fraction of what they need to carry through on it. I'm not sure what the money is for, except I can only assume that it's for the standard cost of putting up a gas tank, which I'm not sure what it is now. They raised the price. Do you know what the
Big
For
bucks.
the detriment, I had heard several presentations on the defensive weight special, well, not really, used to be called that. Well, the paperwork requirements seem to be requiring such secretarial staffs as we would probably not have paper matching, in order to assure that under no possible conceivable circumstance whatsoever will you ever get to that device.
So let's say something that is available to us kinder, they can receive easily and play with and get some useful information. Like temperature sensor, radiation sensor, feeding a digital voice synthesizer to a computer. It says, I have received many rads, the temperature inside my payload is, believe the temperature outside my payload is, believe the time is.
we're talking about radio now, like that,
Yeah, sure. We are finding somebody to give you the radio frequency is going to be the question, because you have to coordinate that, because it's in orbit, you have to coordinate worldwide. So So that's where you run into the rub. IARU or whatever it is.
I don't suggest that because as soon as you show some success or other, you're in this enterprise. Your next edition, you've got something to brag about. You've got something to say. Oh, look at this what I did. As your first step, I'm just saying.
Yeah, I know.
You get
Have it broadcast an advertisement for McDonald's. I mean, they'll pay for it. Yeah, an advertising thing. Have it broadcast an advertisement.
Then you definitely have to have, because in his case, you might actually be able to get away with it if you can talk to the amateur community and letting them put it there. In that case, it's commercial, and that means you have to go through the Federal Communications Commission to get a pre-approval to launch the beast, because they have to issue you a frequency and a license to operate it commercially, and that costs money to apply for. And are you going to make enough money back off of your sponsor? And
But it may be enough to the sponsor to have it just named that, not actually broadcast any.
Well, it's like the Russians were going to have advertisements painted on the sides of some of their rockets. So the TV cameras see them going up.
Oh, we have this 1-900 number now that will record a message to be put in space and so someone.
Yeah.
Certainly sounds to me as though the handprint is a better bargain.
Yeah.
Even if it only lasts for a little while.
say something. Gearing up, so don't be shy.
Well, it looks like we're getting a few ideas. I'd like to get them a little more in detail, perhaps. Either probably written down would be the best idea. If you have any definite.
Something written.
Yes.
How about if we require that we fill up one of these sheets with ideas?
Okay. Yeah, let's get our ideas down. Halos.
Telescopes. A telescope, a common item. Two very diverse light levels. Astronomy, looking away from the ground. The same telescope for a sensor to work at rather higher light levels, looking earthward at the selected items.
Looking back at Earth.
If the telescope is a common item, you need some feature in there, such as neutral density filters, or maybe a beam splitter and different sensors in a switchable between the modes, which where you're going to be pointing. For astronomy, you want very sensitive sensors looking groundward.
Flip mirror, the focus.
Yeah.
Just you have two
Your
sensors
splitter
on either
is-
side, and you have a mirror just flips back and forth. And,
Grab one out of the back of the 35 millimeter camera. If you're going to put an astronomical observer up, you want to try using a wavelength you can't get on Earth. You might try ultraviolet. And that'd be the excuse for having it in orbit, is the fact that certain wavelengths of ultraviolet you can't get on the ground. Infrared is really
Infrared observers, you can't get it all, so it's,
well,
Oh, that's better. Yeah, he's already got IR on there.
Yeah.
Wavelengths you can't get on the ground, then sure, we can.
First observing
Sensor.
scope with the astronomy low light level as the other option for its operating modes.
What is the highest altitude that balloons have been to? Does anybody know?
Balloons?
Yeah, is
About
it-
180,000 feet, something like that.
52 kilometers. Should be the same thing.
Which
I
is
heard about 120,000 feet is the highest they operate at routinely, because beyond that,
I think the record is 100 feet.
the pressure drops.
I wondered if maybe a small experiment might be something like you go up and your balloon that comes out, instead of being a balloon or something, is a helium balloon. And then you have you know, it comes back down, but that might be, you know, a way to get one as high as one has ever been.
Well, it's not going to go any higher.
Yeah, I know. But I mean, it might get you to an altitude higher than one has ever been. You just used a rocket-launched balloon instead of a balloon-launched balloon. Would that be higher than one has been? I don't know. At 15 miles, if we could get 20 miles.
You have this Mylar bag, you have to put enough helium in to get it buoyant at the ground, but it can't expand so much that it rips the bag once it gets to altitude. So if you have something that you can inflate at a very high altitude in the first place.
Yeah, that's what I mean, is you get up there and you're at apogee, your canister opens.
Right.
And inflates your balloon there.
You might have a problem with just whatever residual velocity you got at apogee tearing the balloon apart. That'd probably be your biggest problem, because your balloon is going to be very thin, quite fragile.
Yeah, that's right.
And then when you go to suddenly pressurize it, you just pop it. If it's got any folds at all, they form stress areas.
There may be a way around that. I don't know.
Pressurization rate is out there.
Yeah.
It'd be kind of interesting perhaps to release, you know, if you got it up, release it at that. Don't let it come back down the rocket, release it.
Yeah.
And then have it
What I
come
was
down and
thinking
have it
of,
return from wherever it lands.
You might want to run it all the way up, inflate it, and let it come down.
Oh, that's what I mean. That's what I'm talking about. Yeah, run it up in the rocket body. And at apogee, it, you know, separates and inflates. The rocket, you know, falls back, comes back by parachute, whatever. Your balloon comes down slowly on the breeze and lands wherever in the world it lands. You know, with a
It might
message
not
to
come down
return
at
it.
all.
Yeah.
That might be interesting in itself.
Yeah.
She goes and eventually the helium tends to migrate to the
Right, yeah,
you've gone out of gas, eventually it'll come back.
But it might be in a way to do something that's never been done before. You know, a Guinness record sort of thing. You got one higher than anybody else ever got. It's a rocket launch balloon. I don't think that's ever been done.
I don't know.
No,
I've seen a balloon launch rocket, but I've never seen heard of a rocket launch balloon yet. That's kind of turning things
Excuse
on
me,
its
but we
head.
do have a member who's very involved in looking into the raccoon concept, which is you're talking about.
Oh, it's not gonna work.
That's not what he's talking about. He's talking about the opposite. No, he's talking about carrying a balloon up as a payload.
Oh, it's the opposite way.
Yeah. But she's talking,
Turn it upside down.
what she's talking
Yeah.
about is having a balloon carry a rocket to high altitude.
Oh,
firing
okay.
it
I've
off.
heard of that. Yeah.
Yeah.
Now I was thinking that you launch your rocket and the payload is a, you know, collapsed balloon in a canister with its gas canister or whatever. And it gets up to apogee, opens up, inflates the balloon and releases it. And that comes down, perhaps telemetering its existence. Here I am, so somebody can go fetch it.
Use aluminized mylar.
It's interesting because it is an exact opposite type of
That's
thing
right,
that one of our
because-
members are proposing, which is
straight out.
the other way around.
Because you see, with that concept, you're trying to see how high you can get your rocket before you fire it off in order to keep more
Right.
altitude with a rocket payload. Here we're trying to see how high we can get a balloon. In other words, it starts out high and then comes down. That might be a way of getting up a very long duration balloon. Because if you inflate one at the ground and let it go on up, it's losing gas all the way. If you start it up there, it's losing gas from on top. Tend to stay up a lot longer. I would think, assuming it doesn't tear itself apart and so on.
There would probably be some folks at universities interested out there for high altitude wind sonde.
That's right.
Yeah, you can probably get it.
Bet you could.
So essentially, you want to beat the commercial people that are threatening to put the Pepsi-Cola balloon or the Fuji balloon into orbit and with backlit illumination so that as it sinks as the balloon sinks slowly
west.
That might be an idea. We could get somebody sloping on the balloon.
Oh, well, they're already thinking about that. That's what I'm saying. That is already.
You might be able to get somebody to sponsor it, just
monstrosity.
I mean, after all, you've seen these racing cars, go watch Indy this week, they're gonna have all kinds of stickers on them, everything from Champion spark plugs on down, they have stickers.
They've got balloons now that are shaped like castles and all kinds of strange things floating around.
Well, those are mostly qualified air balloons.
Yeah, I know, but still, that.
Problem is, at the altitude this beast is going to be operating at, how many people are you going to see this thing,
Something like this, I'm wondering.
Hey,
You gotta have
The next step is to put a camera on it, hang a camera
Yeah.
on the balloon to look at it.
Well, I was thinking with something like this, it has Newborn on it hanging from the balloon and something saying, here I am, a beacon. How many times it might go around the world and follow the jet streams wherever before it finally comes to us?
Well, but you see now, there's another aspect of this thing. One of the things that makes this stuff so interesting is that, for example, astronomy is still the place where the amateur can make contributions to the field of knowledge. And it looks like amateur rocketry and amateur space payloads, maybe we're struggling then to get that into that same category. That is to say, are there things that still can be discovered? Are there questions that the so-called big shots can't be bothered to try to ask or try to solve? And once you find a question like that, it may be too technical for you to understand, but it may be too trivial for these people to try to figure out. And maybe there's some interesting areas that haven't been explored, and that's where you should be looking.
Different kinds of astronomy. For the larger field, asteroid search.
Well, that's possible. There you go, asteroids from orbit.
So we have some
There was an article on a
long-term
Schmidt
missions
telescope in Astronomy magazine.
for ideas,
I
but
think it was
they're
last
at,
month.
they're at a level, oh, I'm sorry.
Yeah, he's talking about astronomy. There was a wide angle way to make a wide angle Schmidt telescope in I think it was Astronomy magazine just a month or so ago. He was using a 10-inch diameter spherical mirror. I happen to have an Edmund scientific catalog around the house, and they actually had that size in it. And you can get a gold for infrared, which would be the thing for asteroid search. It sort of adds up. I don't know whether you want to try it or not. Just an idea. Well, it can weigh a few pounds, sure. You've got
Under the
segment class mirror, it's about this thing. You
Well,
can have a few pounds of weight. Most of the telescope are just a tube. And
Under the asteroid search, it occurs to me that there have been people that have been somewhat upset by the fact that big things have come very close to the Earth. I say within, what was it, 330,000 miles? Which is
I think they got 180,000 last year.
Oh, really?
Yeah.
Okay, well, in any event, some people are more than whatever upset about that sort of thing. If you were to, under your asteroid search, if you were talking about looking for ways to figure out whether or not, using a wide field camera like that, to figure out whether one is coming this way.
oh, it's in Arizona, it's Shoemaker, and the asteroid watch.
Yeah, they have a 36-inch telescope.
Right. In addition, our group has entertained 3 different medium to long-range proposals. One includes an asteroid penetrator mission, which originally was configured with a radio transmitter, such as maybe on a ham frequency that could be tracked in its orbit. That has been considered as a near-Earth asteroid mission. So don't get the idea that we're trying to go beyond Mars.
The delta V to some of the near asteroids is smaller than the moon.
Yeah.
So
And there are a lot of
navigation problems, but
well, no.
a lot of navigation problems, but it's less of a rocket motor to get to.
Today, there's more of those asteroids being discovered. I was talking to someone a couple of years ago, talking to the skyrocket business. They had found 5 asteroids. So they are turning up asteroids all the time. They are using a 36-inch telescope. In 2 years, they're going to switch over to a 74. They're using a CCD camera on that. They use the same camera. And their main problem is keeping the camera
if we do a CCD, our CCD, we're gonna have to do thermoelectric instead of
Well, you can
coolant.
You don't actually have to have a cooling system on the camera if you can keep it cold enough. You can run enough dark frames on it and sort out the noise that way. It's not as effective because you're still going to have a lot more thermal noise, but you can get picked up to a CCD camera without running a special cooling system.
Yeah, it uses kind of, I don't know how lovely it is for this kind of application, but something have to do with environmental, like picking up space, like seeing how much space debris or, I don't know, what's being.
Once you've got,
Probably get some money and say something about it.
Oh, you got, yeah. Here's the thing, robotics, somebody to go after all those little bolts and stuff that was left behind.
somebody had
Do a scavenging service?
somebody had a nice poster on it.
And then kick it back,
They're
yeah.
trying to talk him into running a paper, he ran about 150.
Yeah,
He's got to get it, he wants to try. It doesn't, it's not a huge robotic, it's got a gas catcher. He got something like that with 4 or 5 layers, he wants to ram it. It doesn't need a whole lot of robotics, he needs a trajectory.
That could combine with your balloon deal. In fact, you can put a balloon up in orbit and you fill it with foam, something that creates foam, a low pressure system, and it will harden. If it picks up anything, it'll bring it back down with it. When your balloon is expanded, then you got a higher drag.
Depending on how hard it hits, you might end up with pieces of foam all over the orbit.
So you might create some more
That's right.
space debris.
Yeah.
Right, yeah, foam hits real hard.
However, you get your balloon up on orbit and melt a batch of aluminum, plate it over the inside, and next time the shuttle comes up, they can put an airlock on it, clean up. While we're on the topic of asteroid penetrators and space debris and whatnot, take up a meteorite that has struck the Earth, an asteroid that has struck the Earth. There's one that's passing around back there. Take it up on the missile and drop it back. Like that one right there. Drop that from 20 miles up. That would be kind of interesting. Drop it back. Yeah. On the other hand, how many people see a real one come in? Well, you just create the circumstance.
What is the purpose
So
of
it's not
this?
going to be coming in at
Oh, it won't be going quite that fast. That's right. That's right. But anything that size doesn't come in that fast anyway. Once it gets down to about 6 miles off the surface, it's going slower. That's right.
You'd have to have a retro fire on it, or...
No, that's...
No, let it hit. That's right. Let it hit.
What is the purpose of
See,
this?
one that size hitting the ground essentially hits the ground and bounces. Okay, that's not even going to make a crater, or even a hole for that matter, depending on what kind of ground it hits. But it would be interesting just to be able to go over and pick one up that has just come down. And essentially, there's no difference between dropping it from 20 miles, or even 6 miles for that matter, than a real one coming in. There's really no difference.
What is the purpose of doing this?
I haven't figured that out yet. It's just essentially, letting people see what it actually looks like for one that size coming in, because that's what it would look like. Assuming you can actually see it coming
We're
down.
getting into ABM 3D violations.
Oh, we're not hitting it, we're letting it drop. We're letting it come in.
No, as far as I understand the ABM treaty, that in no possibility...
Not necessarily from orbit, but just even our sounding. So,
It makes
as long
no
as it's
sense
over
to
6
describe
miles, it'll have the same velocity as an actual meteorite coming in.
ballistic missile.
Say it was an accident. Man keeps it up there.
That's from the Behringer one.
Hold on,
In Arizona.
there's going to be a meteorite there.
I don't remember. I have a book that tells me, and I don't.
Where's the land?
Way to find out.
Which hand did it land there?
There are a number of books on
If you did it such that you could see it land, as many as possible, people as possible out to watch it land, that would be no different from seeing a real one coming. It's just that we never get the advance warning of a real one coming down, and here you
That
go.
height, the friction wouldn't really burn up too much.
Well, it wouldn't do anything to it.
So you can do this over and over and over.
It would be colder.
You hard to envision to see the meteorite hit.
Yeah.
See, the way it physically works, when a meteorite of, say, 100 tons or less comes in, it may be going 30, 40,000 miles an hour, but by the time it gets to about 6 to 8 miles off the surface, it has burned off so much of its speed from about 6 miles that essentially it dropped rock. Okay? So if you drop one from 6 miles, where you actually have a real one coming in, the velocity it's coming down after the 6 mile point is the same. There's no difference.
You're interested mostly in
You can photograph
the
it
last,
coming down.
the very last,
That's right.
before it hits, or as it hits.
That's right.
Rather than going through the atmosphere.
That's right. You can also demonstrate what happens when one that size actually hits. You know, show people this does not make a crater. It does not explode. It essentially hits the ground and bounces.
Probably any piece of material of the same density and size.
That's right. Although to get something that density and size, essentially you need nickel iron slag or something like that in order to get it. I mean, it's pretty good grade of nickel steel. But as long as you're simulating it, you might as well simulate it with those real ones. I mean, they're available.
I don't know if I'd want to insure the front row seats to that.
Well, even if you're some distance from it, you know what your apogee is going to be. You can plan with your wind speed and everything where your rocket is going to be when it dumps it out. And so you can plan where you're going to be and where it's going to land within a very close circular area of probability. And you can have cameras set up to catch it as it comes down, to photograph the impact, record the whole thing. That would be probably the first time anyone has ever photographed an incoming meteorite. I mean, all the way to the ground. All the way to the ground. I think except for going over and photographing it after it's on the ground, we're seeing them streaking through the atmosphere. But I don't think anyone's ever photographed one as it came down and hit.
I don't think they've ever caught one hitting, but it's not uncommon to photograph them coming in. In fact,
oh, that's right. Yeah.
In fact, they used to track them incoming. They have two cameras set up, two cameras, and then from the triangulation, figure out where they've landed, and go pick them up.
And DSP does that every day. Sees the fireballs come in, but I don't think one's ever been photographed in.
No, actually there have been very few that have been photographed coming in and then found afterwards.
Yeah.
It's very rare.
But this wouldn't be a first time.
There have been one or two that have been found where they hit something or somebody.
Yeah.
Didn't they have one a couple of years ago, hit somebody's car in the driveway? Quite some years ago, they had a woman on Connecticut, one landed on the house and came in.
Okay, the one that hit the car, will be described in tomorrow morning's asteroid talk and asteroid defense systems. And there was one that landed within 5 feet of a kid standing in his front yard in Noblesville, Illinois. Scared the hell out of him. And there was one lady whose house had been hit twice by meteorites. So she sued NASA because she figured they should have taken care of the problem.
I was trying to tell her something.
Yeah, like move.
It just occurred to me, I can't understand why it hasn't already been brought up in the last 2 minutes, I believe. I know of at least one person who has been hit by a meteorite, and it was a woman, I believe. She lived here in this state, Alabama.
Bruised her head.
That's where she was bruised. I don't know if that's where it hit her.
I remember that makes a lot of things. Somebody in Connecticut.
As far as I know, that's the only person who's ever been hit by a meteorite.
Yeah, there was a horse killed by one.
I say, with that in mind, I think you'll find it very hard to find support for a bombardment mission.
Whose car are you
Regardless
looking
of
at?
how unlikely it is that any particular person is going to be hit,
Well,
you will have trouble explaining the risks.
Well,
however
you have to fire your rocket over a safety range area anyway. Okay, so it's going to come down under your safety range. We're not going to be dropping it over follow the current. Your rocket can't be fired over that, just the safety rules.
In other words, you're saying since you've already got a safety range, it doesn't matter
That's right.
whether you drop something on the rocket or not, because you've already,
Yeah,
the
if
thing
you drop it on your
is
safety
designed in case you drop
range,
the rocket.
your rocket's going to come down there anyway.
Getting back to the satellite payloads, I was just reading here that Dr. Knopf is suggesting some accelerometers measuring the vibrations and so on and so forth on the trip up. Give you an idea of just how rugged your device has to be. You know that if you're doing astronomy, you're going to have a certain amount of platform stuff, rate gyros and star sensors and so on and so forth, which might be a challenge to build for somebody who doesn't already know a design about how to do that. A rate gyro might be quite a design problem for an ME student. I'm just trying to find a way to get a larger group than just the people in this room interested in the project. You have to consider, I would say, consider the entire history of satellites and find some of the high points along the way. There's a considerable amount of aviation activity in duplicating some of the early flights of aviation, and perhaps an amateur spacecraft society would do well to emulate some of the milestones in the creation of satellites. Whether you have to go all the way back to Sputnik or not, I don't think you probably have to do that. But the idea being that anybody who pays attention to the program will be not only participating and getting an idea of what the original people that had designed these things had to go through in order to think about this stuff. We are the benefactors of considerable body of knowledge about space and spacecraft and so on and so forth.
We're doing it with, as much possible, current off-the-shelf equipment. What was very, very difficult to do at the time and a lot more bulky at the time.
And you demonstrate at the same time the amount of advancement that's happened. Like if you're duplicating a 1964 experiment, then with 1994 technology, you've got a 30-year span there, and you can say, listen, we got off-the-shelf accelerometers, we got off-the-shelf this, that, and another thing. And you're also demonstrating some of the basic principles of spacecraft and space flight. But not everybody understands. I mean, most people who look at Star Trek and other space-based arrangements figure that this is all pretty ho-hum. They don't know what's going on under the NC-1701 hood. And to that extent, they're being hoodwinked. Because there's a lot going on that should be going on that they should have to explain, but they're not. And they can get away with it because nobody appreciates it.
Yes, I understand what you're saying, and I think you've got some good points there. The one thing that I think we should do is probably involve schools in our projects. That would probably increase our visibility, get students involved in some of the work. In addition, we have, or at least I have, developed a bibliography which is in one of the postings in those notes. I posted a newsletter recently to the topic in the messages. Among that, at the bottom of that, is a bibliography of a number of books, including one published by AMSAC, which is partially a history of their efforts and their technology that they use. That is a base that we're starting to work from as well.
I think that the post you took cut off before you took it, put that early June, did you? Cut it off mid-May?
Yeah, it happens to be in between those two. It's on the disc there.
Okay, it's on the disc, I'm told. But I think it's getting on here, and I suspect everyone doesn't want to stay too long. Busy day tomorrow. We've got some definite projects. I want to make sure of one thing. All of those left here that are interested, that we get information from you as to how interested you are. If you filled out the membership forms, we can collect those from you, as well as any dues that you would like to contribute according to the levels that we have. And beyond that, we'd like to send you a report on what we're doing based on what you've given us. So we want you Even if you haven't filled out the membership things, we'd like to have your name and addresses. So at least fill out the membership thing with your name and address, or you could sign up.
Basically, I want to know if anybody wants to work on any of the projects we've talked about now. You want to do it?
I would like to, and find out where we Kansas.
Anyone here willing to do some work on these? Okay, I'm gonna nod over here.
I kind of like this idea about demonstrating how, you know, where we come from, what's been happening. There's a general lack of appreciation for problems that have already been solved once, and I think that's a worthwhile thing to demonstrate. That you know, a lot of people that are very hot in there and they think they know what's going on, and they just demonstrate to them these problems are not inconsiderable. It's like the ME. Has anybody seen the ME experiments? The mechanical engineer, like they have at MIT. Seen Dr. Flowers' demonstrations on, I think it was on Scientific American Frontiers, which they give a moderately complex mechanical engineering task and say there's no parts. They learn more. They learn a great deal more about what goes on than you do otherwise. And I don't know whether we deserve to have a competition here, but certainly it seems to me that you've got a lot of.
It's not a bad idea. Just go out to different university mechanical and electronic engineering departments. We have a proposal. We have an idea for doing X. Send us your proposals. Do you think you're or better yet, send us your hardware, and the one that works best will fly.
Send us your money.
Hey, if we get hardware off, that's half the battle right there. That'll get them interested. Send us your hardware, and we will arrange to get this beast flowing. As if we can get ourselves a launch option here.
You get a certain amount of alumni support as well.
Yeah.
We want to see the tie roll in orbit.
Yeah, so now you're talking.
Go Dogs. No, the tie. I don't have any idea. I'm just saying.
Pick 3 or 4 schools and get an intercollegiate competition going.
And that was worked well for the solar cars.
Yeah, MIT and Caltech got into a real dog right there. Why don't you try that?
You know, there's supposed to be a scheduled solar sail race.
1995.
1992. Never ain't happened because they can't get the bucks for it. Get the launch done. Launch is the killer.
They need the launch. They need the altitude at launch. They can't get high enough altitudes at launch.
I mean, they have at least one test.
Money to get the launch.
The problem is your deployment low altitude is not residual air drag. It just messes them up something terrible. So you got to get a high enough launch. The current vehicles are not flying high enough to get us launched.
Okay.
And each haven't got the darn things.
We'll keep in touch.
Maybe because they got folded up and so on and so on.
Well, yeah.
She's your telemetry system.
Thank you. The telemetry on a
Charles see all of it.
emergency parachute. Most of it's flight hard. When we're in the car, there are bars right now. There's a breadboarded version. I got changes to make it. I'm going to put it on.
Circle numbers.
Any way you want to do it, it's fine.
You realize still what? Because of the conference schedule, like we all need
Right. You'll get a second.
Okay, we're just got together. We're
You'll be some